we're going to solve equations that are quadratic in form. And so these look like they're quadratics, but they're not. And the easiest way to do this is to use substitution to make them quadratic and then solve them. So our first example is going to be x to the fourth plus x squared minus 12 equals 0. And so what we want to make sure is that this power is twice this one. And if it is, then we let our u equal the smaller of the two, the x squared. So when we square it, we get the bigger of the two. And so now we can rewrite this as u squared plus u minus 12 equals 0. And this can be solved by factoring. We have factors of minus 12 add up to 1, our u plus 4, and u minus 3 equals 0. So then we get u equals minus 4 and u equals 3 is our solutions for u. But we're not interested in u, we're interested in x. So we replace this with x squared, and we solve using the square root formula. So we get x equals plus or minus 2i, and x equals plus or minus the square root of 3. And with these 4 answers, we're ready to do what we need to, and we have our 4 answers. We started with an x to the fourth, we ended with 4 answers, so our 4 answers are the set 2i minus 2i square root of 3 minus square root of 3. And we found all of our answers using substitution. The key here is to remember whatever you start with is what you want to end with. Don't stop here or you're not going to get your answer right. Let's look at another example. Suppose we have z squared minus 5 squared minus 3 times z squared minus 5 minus 4 equals 0. So here we're going to let u equal the quantity z squared minus 5, so that u squared is the quantity z squared minus 5 squared. This changes to the following. And so this factors as u minus 4 and u plus 1. So u is 4 and u is minus 1. But we're not solving for u, we're solving for z. So we replace u with z squared minus 5, and we add 5 to both sides of both equations. To get z squared equals 9, and z squared equals 4. When we use our square root property, we're going to get z equals plus or minus 3, and z equals plus or minus 2. So our final answer is minus 3, minus 2, 2, and 3, just to write them from smallest to biggest, but it doesn't really matter, just make sure you get all 4 of them in there. Again, we had a z squared squared, which is a z to the fourth if we would have FOILed this out, and we ended up with 4 answers. Now, for our last problem that we're going to look at, in this example, suppose we have 3x minus 5 square roots of x minus 2 equals 0. So remember, this is the same as x to the 1/2, so we're going to let our u equal the square root of x so that our u squared can be just x. But because of this, we have to make sure that we're positive. So we end up with a 3u squared minus 5u equals 2. 3 times minus 2 is minus 6. Factors of minus 6 after minus 5 are minus 6 and positive 1 divided by 3. Reduce our fractions and change our signs to get u equals, let's make sure this is in blue, 2 and u equals minus 1/3. Well, if u is 2, that means that x, the square root of x equals 2, or the square root of x equals minus 1/3. So when we square both sides, we get x equals 4, or we get x equals 1/9. But again, this one won't work because a square root can't equal a negative number. So we have to rule it out. And our answer is just x equals 4, which we can plug back in and check.